determining the components of a force. Dimensions are not always given in horizontal and vertical direction. We take notes. Dimensions are not always given in horizontal and vertical directions. Angles need not to be measured. Counterclockwise from the x-axis. From the and the origin of coordinates let me write in here and the origin of the origin of coordinates needs not to be at the line of action of a force. Therefore, it is essential that we be able to determine the correct component of a force, no matter how the axes are oriented or how the angles are measured. This picture provided here, these two pictures, suggests a few typical examples of vector resolution in two dimensions. Consider this picture. For example, in this picture, in this case we have the x and y direction. F can be written as fx plus fy. F sinus beta beta j. In this case we have the direction of x is different and beta is also different. In this case if we use the component f cosinus beta in the y direction, and beta j. The third case, the beta is also different and the component is different. In this case f And the last case is also the x and y component is arbitrary and chosen in this direction. The angle with f and beta minus alpha, we should obtain the f component here, y and x. We need this angle which is beta minus alpha, f. For different various angle and coordinate and also origin are shown in this picture. Rectangular components are convenient for finding the sum or resultant r as shown in these four pictures of two or more forces. Consider two forces F1 and F2 which are originally concurrent at O in this picture. Consider this picture for another resultant example. F1 and F2, which can show with the vector form F1 and F2. These two vector forms, which are originally concurrent at a point O. Figure 2.7 show the line of action of F2 shifted from O to the tip of F1 according to the triangle rule. In adding to the force vector F1 and F2, we may write R F1 plus F2 in the unit vector Fx F1x I plus F1 yj F2 xi plus F2 yj. The resultant Rx R so as a result we can write Rx F1x plus F2x R F1y plus F2y. The term sigma Fx sigma Fy can be used for the summation. We can also find another specification of the resultant vector. For example, theta is tangent inverse Ry on Rx sigma Fy Fx in this case we can also find the component of F2 if we have this theta, for example theta 1 and theta 2. We can find the component of f2x, f2y, and other component of the vectors.